Okay, so yesterday we talked about this bell-shaped curve, how it's split up, all of these values underneath. This is called the empirical rule. All the shaded area, the percentage underneath, tells us about the data, right? This is a normal bell-shaped curve. So I wrote empirical rule for you. The mean is that symbol mu. That always goes in the middle of my bell-shaped curve. That's the average, right? Makes sense, goes in the middle. But today I'm introducing something new called z-scores. A z-score is basically the same thing as a standard deviation. If I'm at my middle and I say 1 standard deviation above, I can also use the phrase 1 z-score above, 2 z-scores above, or 1 z-score below, 2 z-score below, 3 below. So z-scores and standard deviation have the same meaning. And the way that I find a z-score is this formula. My data value minus the mean divided by standard deviation. So in my notes today, I'm going to talk about how z-scores are going to be used to like kind of dig deeper. And what if I want to know data that's not perfectly on 1 above, 1 z-score above? What if it's like half above? And it's not a perfectly sectioned off line. So that's what we're going to talk about today. Our notes begin at the top where it says 11.4 day 2 z-score. And it's right here. Oh, okay. So I'm starting right here. Z-score. I wrote the formula on the board. It's up here because you're going to need it today. We're going to use it a lot. So we're going to calculate everything by hand, but I do want to let you know that graphing calculators also can calculate z-score, but we're just going to do it without a calculator. You will need a scientific calculator though, because we are doing subtraction and division today. A z-score counts how many standard deviation something is above. So that would mean that my z-score is greater than 0 or below. That means my z-score is less than 0, above or below the mean. Remember, my mean is in the middle. So with this, this is called standard distribution or a z-score graph. Okay. The standard deviation is 1, right? 1, 2, 3. So we call that a z-score. So instead of using the word 1 standard deviation above, I'm going to say it's the z-score of 1, z-score of -3, okay? So you use z-score when data values are not an exact integer. What if I said, you guys, I want to know the data right here. What's this? What percentage is shaded right there above? Or what percentage is shaded below this data value? Okay, so that's what z-score talks about, because I'm not giving you a perfect, oh, it's 1 perfect, 2 perfect. Z-scores give you any value. So here again is the formula. We're going to be given a value, we'll be given the mean, and we'll be given the standard deviation. Okay. So let's scroll down. Okay. Here we go. That's too high. Sorry. Ella and Alicia are comparing scores in their college entrance exams. So, as you know, there's the SAT, and the SAT has a perfect score of 1,600. Ella's SAT score was 1380. Alicia's ACT score. So Alicia took the ACT. And by the way, in case you cared, a perfect ACT score is 36. Okay. So Alicia's ACT score was 32. The mean SAT score, my mean, remember this symbol, is 1,000. With the standard deviation, I can start using, that's a horrible drawing of it, but looks like that. Hi.
Can I grab Ari and his Chromebook real quick?
Yeah.
Thanks.
So mean is 1,000, standard deviation is 200. So what I'm going to do right now is I'm going to make a curve for the SAT using 1,000 as my middle score, right? So here we go. A bell-shaped curve is just a nice, even looking, and that, you know what, that is like so perfect. I love it. I love it. I love it. The SAT, 1,000 is the mean. And I'm supposed to go up by standard deviations, up by 200s. So 1,200, and I go 3, I always go 3 to the right. 1, 2, 3, and 3 to the left. $800, I'm going by 200s, right? Because that's my standard deviation. So my range right now of my bell curve of my normal distribution is from 400 to 1,600. I suppose somebody could get a 400. They would basically be bombing the SAT. It would be horrible. Oh, this is like... Okay, so now let's talk about Ella. Ella got a 1380. So here's what I'm going to do. I'm going to use my formula. It's up here in blue. 1380 minus the mean, minus 1,000, divided by my standard deviation. There's the formula. It's in blue. Ella's score, 1380 minus 1,000 divided by 200. Can you please do that on your calculator? Grab one if you. Okay, what's that decimal? Read. 1.9. 1.9. So she is 1.9 above the mean. That would be right here. One standard deviation, 0.9, like right there. 1.9 above the mean. Okay, so I practice using my formula. Ready? ACT. This is Alicia. Okay. Alicia's ACT score. Well, first of all, let's map out what the ACT looks like. My average ACT score, the mean is 22. 22 goes in the middle. My standard deviation of the ACT is 5. So I'm going to go up by 5s. 22 is my middle. I go 3 to the right. 22 plus 5, 27 plus 5 plus 5. It's really small. I don't know if you can even see that. Sorry. Then I go 3 below, which I realize I should space out a little better. I go by 5s because that's my standard deviation. 22 minus 5, so 17, 12, and 7. Alicia got a 32. Here I go. Alicia's score, 32. Take away the mean. What's my mean? 22. Divide by my standard deviation. All right, calculate it out. Probably do it in your head. So easy. No, you already helped. Someone on Zoom. Sorry, guys. Someone on Zoom.
Z is equal to.
The z-score is 2. That means 2 above the mean. So if you're comparing 2, 1, 2, Alicia did better because her score is higher on average. Her z-score is higher. That's what z-score means. Her z-score is higher. Okay. All right, let's keep going. I need to use this information because the next problem, how does the 1120 compare to a 23? So I'm actually going to keep some of my data up here. Okay. So I'm going to keep what's important. If you have an SAT score of 1120, that's the number that I plug in minus my mean. My mean is 1,000, so I'm going to subtract 1,000, divide by the standard deviation of 200. $1120 minus 1,000 divided by 200. What is it? Someone here, because Zoom just went. New person here. Right? I'm gonna know you, but Sarah.
0.6.
0.6. That's not very much above the average. I don't know. Now, an ACT score of 23. 23 minus the average divided by the standard deviation. You have that one ready? Give me like 5 seconds so people can try it. So 23 minus 22 divided by 5. So, Alex, what'd you get?
Z equals 0.2.
This means that getting an 1120 on the SATs is better than getting a 23 on the ACT. Okay. All right. Before we do example 3, I want to have you turn and I'm going to explain to you what these charts are on the next page. So go to the chart that says negative z-score. The top of the page says negative z-score. So flip to here. Okay. This is if I have a negative z-score below the mean, right? Isn't a negative z-score mean it's below the mean? Negative. So I want to show you what this is. Let's say that I had a z-score and I wanted you to tell me what z-score translates to negative 2.26. Less than or equal to negative 2.26. So you're like, what? Okay. Let me show you what the left column means and what the right column means. And I can even, can I? Yeah, sweet. This left column, the axes or whatever you say, has the Z. This is the ones place and the tenths place. So this says like negative 1.10, and it doesn't tell me anything else. If I go here and I say negative 1.1, and then I wanted negative 1.11, I would do negative 1.1 is 1.13350. This is negative 1.2. See how the 0.2 is a negative 1.12. Negative 1.12. Negative 1.13. See the 3? So I use this chart only the ones place and the tenths place is on the left. The hundredths value is up above. The example that I gave you is negative 2.26. So I'm going to go to negative 2.2, 2.20, 2.21, negative 2.26, right here. Right there. This value, 0.0, or 1.191%, right? If I change the decimal to a percent, this percentage means like what percent on my distribution bell curve is this value. Negative 2.26 on a curve is like, it corresponds with the value of 1.19%. So I'm going to use my z-score on example number 3. And you actually do have some problems in homework. Homework tonight is on Pearson. And it gives you questions like this, and it says, you know, find the exact value of the z-score. So I want to know, since this is all negatives, that means that this chart is all the shaded region values, percentages here. Okay, this is the negative z-score. Below the mean, negative, left. Turn and go to the next chart. The positive z-score graph. This means above the mean. So look at all these numbers on the left are positives, right? So let's practice. This is 0. This is exactly the mean, but I'm now looking at like z-scores like up here. So it's not going to have any negatives on it. Here's a practice. Practice. Find a z-score that is like 2.23, positive 2.23. I have to scroll up. You can find 2.2 on the left-hand side. You need to find the 0.03 up above. .2 is right here. Then the hundredths place says 3. So I go 0.01, 0.02, this one, 0.03. To see how it matches up with my 0.03 up above? So a z-score of 2.23 is high. That's good. That's 98.71% of the data. If you had a Z-score, like let's say that on your SAT, you got a really great score and you calculated your Z-score and your Z-score was 2.23, that means that you are in the 98th percentile of scores on your test. You did really good. A high Z-score is really good. But Z-scores don't go up to like 20. It caps out, as you can see on our chart, at 2.4 on this chart specifically. Okay. So practicing plain old Z-scores using the table. You need to know how to do that. And we've also got that formula. So let's go back to the gorilla problem. It's example 3. So back to gorillas. Let's learn about gorillas. Okay. The weight of a captive, okay, living in a zoo. This is not a free gorilla. Okay. A captive adult female lowland gorilla, okay, lowland, not crazy mountains, is normally distributed with a mean of 82.3. The standard deviation is 15.33. Calculate the Z-score for Sasha. You know, the zoo gives animals names, of course. Sasha weighs 61.8 kilograms. The average weight of a female gorilla is 82.3. Sasha weighs 61. Sasha's underweight. So right away, that's something that you could say, oh, well, since she's underweight, she's under the mean, I'm gonna have a negative Z-score. Yeah, so you can make these connections. So I've got Sasha's value, 61.8, subtract the mean data. My mean is 82.3, is the average female weight, divided by my standard deviation. Okay, do the division. Someone new, tell me. Yeah, Josh.
I got like a negative.
Yeah, you're gonna get,
1.33 or 1.2.
let's do negative 1.34. We'll round to the nearest, because I want 100th place when I do Z-score, don't I? So she's below the mean. We already said that, she's underweight. Since Sasha is below the weight, that means that she is, dun, dun, dun. What's the average? 82.3. Sasha is, because I'm, you know, if my standard deviation is by 15s, 82 minus 15.3, I'm just gonna do that. 67. But anyway, Sasha is negative 1.34. Here's what that looks like. Negative 1.34. Maybe like there. So what does that mean? All of this is the gorillas below her. What's that going to be? Let's find out. How many gorillas are below her? I'm going to go to my table. I use my negative Z chart because my negative Z chart is where I'm going to find negative 1.34. Go to your negative Z score chart. Negative 1.34. So let me, 1.3 is where I begin, and then I go to the hundredths. Okay, Ari, tell me what you got.
0.09%.
right here. That means that 9% of females weigh less than Sasha. Sasha's she's below. So if 9%, that's like, there's not going to be very many gorillas that weigh less than Sasha. Okay. So of the things, so this is the chart. So I'm gonna, I can go back to the actual problem. I said that my shaded area, wait, where is it? There I go. My shaded area is about 9%. .01, right? Okay, so we're not going to do number 5 right now. I just want to recap. We practiced finding z-scores using a formula. And if I gave you something that looked like this, actually you'll see it on your homework, and I said, this is what? This is what? And x equals 70. And I said, given this data, find the z-score. Do you know what each symbol means? The mu, mu in Greek alphabet, is this letter. That's the average, the mean. My standard deviation, I'm just going to put SD. And this is my, what they call the value. So your math problem would be the value minus the mean. Where are you guys? Maybe Sean, I'll have you move. Like, what was it? Divided by 15. So if given a problem like this, -30 divided by 15, that's an easy integer problem. 2 standard deviations below the average, a z-score of -2. Okay. I think you're good. All right. So I'm going to assign right now, but let me stop the recording first. I'm going to assign Kirsten homework for 11.4 B.